Welcome back to another video, and today we are going to see how you can modify memory in Visual Studio. So before we get started, I just want to let you know that the finale of my Java tutorial series, that video is out as of yesterday, so you can go watch it. It is a 4-hour long video, but what it has is it has the whole series combined into one. So if you don't want to scroll through and click all those videos, you can just click on that video and it will take you through everything you need to know about Java. So just to get that out there. But anyways, we are done with that series. Now we're going to talk about C++. But this video isn't going to be a tutorial. So it is going to be a kind of like a features tutorial of Visual Studio. So I am assuming you know some bits about C++. I'm probably going to make a intro tutorial later, but as of now, I assume you know what pointers and references are, so not too complicated, but you do need to know those for uh me to know. What am I even saying? Okay, you do need to know that for this video. There we go. Almost had a stroke there. So, but we are going to talk about how you can debug memory in Visual Studio. So, to do that, we need to create a program first. We got a let's do a integer called num, and we're gonna set that to -34. So that is a integer for you, and that is a negative integer. So up here we have this preprocessor statement, and all that does is it shortens it to print instead of stdc out, because I don't like writing that all over the place. I like writing print, so I usually define these two lines up here. But that has nothing to do with the program execution and all of that. And now we are going to see how we can modify the memory. In fact, I also wrote a Medium article on this. If you want to read, you can read the article in the description. It's pretty much exactly the same. In fact, I'm basing it off of my Medium article. But if you don't like to read and you like to watch videos, well, this video is for you, because I'm going to talk about a few more things that the article doesn't cover. But if you just want to read like a quick glance, don't want to watch the whole video, link will be in the description for the Medium article. So now that we know that our number is -34, let us try to print it. Very simple, nothing tricky going on. All we have to do is we're just printing the number, and we're going to do std cin.get. All this does is it prevents the program execution with 0. Press any key to continue, because that is just messy and not very pleasant to read. So I'm gonna run this, and then we can see it prints -34. So you can see we have -34 on the console here, and nothing too bad, nothing, pretty normal for a program like this. So let us see how we can actually modify this for it to change entirely. So what we need to do is we'll keep all the code the same. But what happens if I tell you that when we run this program with this exact code, we can make it print whatever we want? Sounds crazy, right? But it's not. All we need to do is we gotta place a breakpoint, just a red circle here, so that the compiler will stop here, and it will allow us to do some nifty stuff with this code. So let us run our debugger, and of course let's move that out of the way, because we need to uh, look at the windows here. So take a look at this. Now the memory view, you might not know because it doesn't default to this view. So I'm going to show you how you can get here. So you gotta get to debug, and then you want to go to Windows, Memory, Memory 1, or Control Alt M plus 1, and that is how you can view memory. So I'm going to click on that, and it'll bring you to this view. So this view right now is your physical memory of your computer. Now the reason why there's a bunch of question marks is because this is a memory for your program. So this might be memory for Google Chrome. It might be memory for other things like File Explorer. It might be memory for Windows, system, operating system. So you're not allowed to access this memory, or actually your program isn't. So that is the reason why there's a bunch of question marks, because it doesn't know what memory goes on here. But if we scroll along, we'll probably have to scroll a couple million lines. So I'm not going to do that. When we scroll along, you'll see there will be actual data that gets represented on here, because that will be within scope of your program. And of course, your program can access its own memory. So right now, you can see that the arrow is on line 8. And what that means is that the current execution is on line 7. So the arrow is always one step ahead of what the current execution is. So what we can do is we can press F11 to continue our execution. Right now everything is paused. And what that will do is it will move the yellow arrow one step down, which means that we will have executed line 8. Because if you look at the local section, our number is initialized to negative 8,589,934. I read that wrong there. Let's see, what is it? Negative 858,993,460. There we go. Not 8 billion. But what that is if you view this in hexadecimal, is 0xccccccc. Now what that is it is basically a default for Visual Studio Debug. Doesn't really have much value. It's just where objects go before they are initialized. In fact, we haven't initialized that yet because, again, we are still on line 7, currently on line 7. Now, once we press this F11, you can see yellow arrow moved, and we're always behind the yellow arrow by 1. So now line 8 has just been executed. You can see we assigned this to negative 34, and now the locals tab updated to negative 34 instead of the negative 800 million thing. And now you can see we have a reasonable number, and that is what we're going to change right now, because we're not going to step forward, otherwise it will just print our statement. Now we can, in my Medium article, I showed you how you can use pointers to access the memory location, but kind of redundant. But just to demonstrate how pointers work, we can do that. But all a pointer is, it's just the memory address of the variable. So when we assign a pointer, of course, I'm just gonna loosely define a pointer here. So we do the memory address of num. So that is really what we're doing. So what happens if we just skip this line and we're just going to take this? And in fact, Visual Studio does recognize that if we go up to our address column and we type and num, so this is just a shortcut, you can see it automatically brings us to the number of the variable. So you can see this is the memory address, and since integers take up 4 bytes, I believe 5 bytes for signed integers. I'm not sure, but you can see that these are the hexadecimal values of the integer DEFF, and now these are single bytes. Now this doesn't really look good, so we're gonna right click and show sign display. So you can see what I did is I showed the integer form. Now I don't recommend this because this view is not that good, because once you have stuff like ASCII characters and other hexadecimal values, it wouldn't be compatible with integer because of that primary factor of 5. Now remember, binary compatible hexadecimal only because it is a factor of 2, 4, and 8. But decimal is a factor of 5 because 2 and 5 is 10. So that is the reason why I do not suggest you use this. But for the sake of demonstration, I just want to show you this is the physical value that this number holds. Now, what we can do is we can actually edit this value by right-clicking and click Edit Value. You can see now you have this feature. We can edit whatever we want here. Of course, we can't really type letters here. We can only type numbers. So let's type 58. Just 58. When we click on it, you can see we change this to positive 58. But since it is a signed display, it is negative 198. That is the reason why I don't want you to use this, because when you change this, it doesn't actually change the value to 58 because of the signed values proceeding behind. That's why we always want to use hexadecimal, regardless if it looks bad. It's just because we want to. Actually, I think we lost our right here. That is our memory address. Let's just go back here again, and that 3A is our memory address. So that's the reason why I suggest you use hexadecimal. If you don't know hexadecimal because you're so used to decimal, well, you have to get used to it, because that is what we're going off of right now. So 58 obviously does not exist in hexadecimal, because, well, I mean, it does, but in hexadecimal I believe it would be. In fact, let us see what 58 is in hexadecimal. So to do that, we will edit this, and we'll edit the value 58, and that would be negative 168. Now, the reason why it is negative 168 is because we are having this 3 bytes proceeding after the value, which determines its basically integer sign. So right now we are in negative 168, but we have to change these 3 bytes preceding. I say preceding, not proceeding, for a reason, because you can see that the sign is preceding, yes, preceding, aka before the value. Now, what's happening here? Because these 3 bytes are after the actual value. So why is that? Because in fact, CPUs do use a little Indian formatting, which means that, for example, we have negative 34. CPUs look at it as 43 minus. What that does is, if you reverse it, you read it from right to left, negative 34. I know it is very counterintuitive, but it's just how it works, so we'll just have to deal with it. So this, again, an integer takes up 4 bytes, so this is the physical location of our num. But once we see here that what we're saying is that the first is the value, the preceding 3 bytes is actually the preceding sign value. So these 3 bytes, which are all maxed out at 255, we have to change that so that it will actually be a positive value instead of negative. So to do that, we are going to just edit each one of them individually. I'm going to change that back to 0. Back to 0 because we want it to overflow back to the normal base. You can see the more we change, the more it increments because of that signed Indian value. So we gotta change this. Okay, now once we change all this to 0, the sign loops and all the bytes reset, and you can see 58 in fact is 88 in decimal because we are doing the thing. And just to prove that I am not messing with the display, we can change this to a edit this value to FF, which is the maximum value of hexadecimal, and you can see, boom, 255, because that's the max value. So that is the hexadecimal display of this. So now you can see we have successfully modified this number to print 255. And just to prove that it actually prints, let's continue this program, and let us see how we can ignore. So let's see if we, and you can see, let me just bring this back up. Oh, well, you can actually see it, but 255 is the modified value, and let's see if I can turn this up. But yeah, so that is 255 right there on the screen, and it's supposed to print negative 34. So obviously we have just in fact indeed modified our memory. So that is pretty much it for this video. Now, one more thing I will bring to you is that we can also modify strings, and that's what our string ASCII display will help us with. So we can do string name, or actually let's do that. Let's do string name or string color. So string color equals red. So this is a normal string, and now once we print color, you can see obviously it'll print red. So we're not just gonna print it. Let us just run it with the breakpoint. And following through, I believe. Yeah, I think. Let's see. Let's wait for it to run. It will build. And oh, duh. Supposed to print color, not red. Print color there. And let us remove that because it's gonna error out. Yep, and it error out because I did not have a declared identifier. I changed that. Alright, let's print that to color. So now once we print this, let's just stop. So let's run this again, this time with the correct signatures and stuff. So let us run, and you can see that it's building pretty slowly, but surely we can let us move this window, follow through back. We're gonna go to the memory view, and obviously right now it's uninitialized, so we have to press F11 or this button here, and now you can see color is initialized to red. And here's our thing. So you can see we have red here. Now this is the reason why this view is useful, because normally it's it's a bunch of random symbols and stuff, but occasionally it is used for strings. So obviously we can see red is here. Now usually you wouldn't make any sense out of the right column. There's just a bunch of random Unicode characters. I can't even understand what this means, but occasionally you will see some ASCII symbols here, aka red, and we can change this. I believe this is, let's see, we can cap 1, 2, 3, and believe is this. This is the byte. Now you can see our string takes up 1, 2, 3, 4, 5, 6, 7, 8. So 8 bytes. Now I think that is the string. Now you can see we have 8 bytes. This is our string, and we also have some numbers down here. What this is if you look at over here, this is the buffers and all the other stuff. So we do have a bunch of other things because string is not a primitive type. But you can see we have this buffer, which is actually just a character, and it's 16 lines. So 16 because we have 8 bytes. Each byte is 2 decimal text decimal digits. So we get 16. But red is here, the 72, 65, 64. So we can edit this to change the color. Not the color, but can change this to, we can do 62 or 63. You can see it will become rec, because rec is C is before D and is exactly one ASCII value before D. So we can change this to 48. It will become RE capital H. So again, and now of course it messes everything up here because all the buffers and stuff have changed. But now we can see that it will work once we let us continue our thread here. You can see, let me just bring this a little bigger. REH, in fact, is our answer. So that is how you can modify strings, and how you can modify a program's memory using Visual Studio. Obviously, this isn't the full thing. You can do much more with this, but this is basically how it works. So hope you learned something today, and I'll probably be making more Visual Studio tutorials, like just these short tutorials. But again, if you had no idea what I said, go check out the Medium article. It has a bunch of more images and code that you can copy and paste. So that would be, that would be good. But I'll see you in the next one, and peace out.